Good afternoon, students.
Good
I'm going.
afternoon,
Afternoon,
ma'am.
ma'am.
Good afternoon.
Good afternoon, Beta. I'm going to share my screen. We are going to continue with the Carnot maps that we were doing last time. Please let me know once you can see my screen.
Visible, ma'am.
Can you? Okay, right. Thank you.
Ma'am, visible.
Right. Thank you. So last time we were talking about the 4 variable and the 5 variable Carnot maps and how a 5 variable Carnot map could be represented as a junction of two 4 variable Carnot maps. We also saw how one 4 variable map could be seen as the concatenation of two 3 variable Carnot maps. And then we went on to solve certain Carnot maps. I'm going to be sharing another screen with you. I hope the screen is visible.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah, we had looked at the grouping procedure in a Carnot map, if you remember, from this PDF,
Yes,
Yes, ma'am.
right? And we had looked at the rules for obtaining the sum of products expression. And we had seen the rules that were right and that were wrong for grouping the ones. After that, we had solved one or two questions for SOP Boolean expressions. Okay, so I think we had solved this one and this one. Is there any problem in what we did last time?
no, ma'am.
No,
No,
ma'am.
ma'am.
Good. So I'm going to take it on from here to give you a little practice. Let us look at some more examples first. So before you look at the answer, actually, I would like you to try out on a piece of paper. I would like you to solve this example. So please see the example number 3 on your screens. The question is, reduce the expression this using a 3 variable Carnot map. Can you see the question clearly?
Yes, ma'am.
Yes, ma'am.
Right,
Yes, ma'am.
right. So I want you to please try solving this yourself. Done? Are you people done?
Yes, ma'am.
Yes, ma'am.
Good.
Yes, ma'am.
So let us see, what are you getting?
C dash.
Is this the Carnot map that you get?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Yes, because the first number is actually 000, that is 0. Then 101, that is 5. Then 010, that is 2. So 0, this is 0, 1, 2, right? And then this was 5. So I have 0, 1, 2, 3, 4, 5. And then what is the last number? This is 110, which is 6, right? This is 6. So what will we get? A will cancel out and B will also cancel out. Yes or no?
Yes, ma'am.
Uh, has nobody found a problem in this question?
Yes,
Yes,
ma'am.
ma'am. 5 is not.
Yes, ma'am.
Yes, ma'am.
A, B dash, C is marked wrong.
Yes, ma'am.
Exactly. That is why I told you, just to check on this, I told you to do it yourself. Okay. So this was a catch. This was a catch. Please see, this is not 5. This is not 5. This is 4. So either the question should have been this term, either it should have been A, B dash, C dash, or I would have got a 1 in this place, in this square. Is this clear or not?
Yes, ma'am.
Okay, because this is 4, this is 5. Okay, so please, for the time being, please treat this as C dash. I think in printing also, sometimes, there are some errors. So uh, just mark a dash here. Then this becomes the Carnot map that we see here. Now, when we try and reduce this Carnot map, we see that A and A dash get cancelled. Now, looking at the columns, I get B dash, C dash, and BC dash. Okay, so B gets cancelled, and what I'm left with is C dash. Is
C
this clear?
dash.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, good. Let us look at the next question then. So, please solve this question now. This question actually, this question. Example 4. So what are these min terms? This is 000, which is the first term is 0000.
0.
The
0.
next term is 101, which is the
5.
next term is
5.
5. The next term is
3.
011,
3.
which is 3. The next term is 110,
6.
which is 6. Yes. So now when I go on to plot, I get 1, I'm sorry, 0, 1, 2, 3. So 0 and 3, then 4, 5, 6, 7, right? 5 and 7. These are the terms for me, right? So is this the Carnot map that you are getting?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, how
Yes,
have you
ma'am.
grouped these?
Ma'am, grouping is not possible in this. Grouping was not possible.
Yes, ma'am.
Is this clear to everybody?
Yes,
In
Yes,
ma'am.
this
ma'am.
Yes,
case,
Yes,
ma'am.
ma'am.
in this case, there are no adjacent squares which contain 1 adjacent horizontally or vertically. Okay, there are squares which are diagonally adjacent, but our grouping rules do not allow us to group these ones diagonally. So that is why we cannot group any of these ones. So as a result, grouping will not be possible. So what is the final optimized expression that I'll have? The expression will remain the same. The expression will remain the same. Okay, is this clear?
Yes,
Yes,
ma'am.
ma'am.
Any problem to anybody?
No, ma'am.
Okay, let us see the next question. Now, this is a 4 variable Carnot map. Please draw a 4 variable Carnot map. Have you drawn?
Yes, ma'am.
Yes, ma'am.
Good. Let
Yes,
us
ma'am.
now represent this expression. Let us now represent this expression in the Carnot map. So A dash, B dash, C dash, D dash is 0, 0, 0, 0, 0. The next one is 0, 0, 0, 1. Okay, so 0 and 1. Then next one is 0, 0, 1, 1, which means 3. And then 0, 0, 1, 0, which is 2. Okay, so actually we will be putting ones in 0, 1, 2, and 3. So the first row is all ones. Okay, let us try and group now. So obviously one single quad is possible here. Yes or no?
Yes, ma'am.
Yes,
Or
ma'am.
should I make
Yes,
two
ma'am.
doublets? Should I make two doublets?
No,
No,
ma'am.
ma'am.
No, ma'am.
No,
No,
ma'am.
ma'am.
Why?
No, ma'am.
Ma'am,
Why?
we have to make the
Because we
maximum possible.
Ma'am, if a
Yes.
squad
Make maximum.
squad
Why
is
do we make
possible,
the
then
largest possible group?
yes.
Why do we make the largest possible group?
Because we need minimum groups, that's why.
For the
Simplify.
maximum reduction to occur.
Yeah, yeah, yeah.
Okay. For the maximum reduction to occur, we make the largest possible group. Actually, this is a very good example wherein you can try doing both. Okay. So on your paper, first you can make a group of these two ones, let's say, and these two ones. Make two groups of these two ones and these two ones, and write down the terms corresponding to them. And then in the second attempt, make a quad of this and try reducing this. What will you get from this quad?
Ma'am,
A
two
dash, B
terms.
dash.
Ma'am, A dash, B dash.
You can see when we look at the columns, C's, there is C dash and there is C, both. So both cancel out. Then D dash and D both are present. So d or d dash is equal to 1, so that also cancels out. So what remains is a dash b dash, which remains unchanged for all these four ones. Okay, so the corresponding Boolean expression would be a dash b dash. Okay, so this is what we are getting if we take it as one quad. I'll leave it to you as an exercise to instead group make two groups of two ones each and try and solve that. Okay, so what you will have is you will have larger number of variables. You will see that first of all, in this case, when we've made a quad, we are left with only one term eventually. So this entire expression, what we are left with is just give me a second, please. Yeah, I'm sorry. So in this case, what we are left with is a single term, okay, with two literals. But if you try making two terms corresponding to the two doublets, what you will have is two terms first of all, and each of them will have three literals. Okay, so there is a lot of difference in making two doublets instead of a single quad. Is this clear?
Yes,
Yes, ma'am.
ma'am.
Right.
Yes, ma'am.
Let us try and do the next question then. The next question is again for a four variable Carnot map. Please try it out yourself.
Ma'am, which one? Example 6, right?
Example 6, yes.
Done, ma'am.
Okay, let's wait for the other people to catch up.
Done, ma'am.
Done, ma'am.
Done, ma'am.
Okay, yeah, let us see. So what we are getting is a dash b dash c dash d dash. So a dash b dash c dash d dash. This is the first square. Then a dash b, and c dash d dash. So this, are you getting the same column?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Everybody?
Yes,
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 ma'am.
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 Yes, ma'am.
So in this case, please see, all A's will get cancelled and B's will also get cancelled because both B and B prime, A and A prime are present. And what is static, what is not changing is the term C dash D dash. So the final reduced expression would be F A B C D is equal to C dash D dash. Is there any problem?
No, ma'am.
No, ma'am. No,
Okay,
ma'am.
good. This clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good, good. Excellent. Let us now look at one more example of a four variable Karnaugh map. Yeah, please try and solve example number 7 on your own.
Done, ma'am.
Done, ma'am.
Okay.
Done, ma'am.
Okay, good. Okay, let us see now. Is this the Karno map that you're getting?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Good. So, how do we make the group this time? So, the first idea is to make two quads, one this and one this. What have you done?
Ma'am, we can make an octet.
Yes.
Yes,
We,
ma'am. We have made a octet.
we should make the largest possible group first. And since we had discussed that a Karno map could actually be viewed as a circular paper with both its end folding to join each other. So these four ones can actually be considered as contiguous to these four ones, right? And so instead of going in for two quads, I should rather go in for one octet. Yes or no?
Yes, ma'am.
So I make a single octet here, making grouping all these eight ones together. Okay, and then now the next step to reduce. When I try to reduce, what do I find? Again, as in the previous case, A and A prime cancel each other, and so do B and B prime. Okay, now let us have a look at the columns. So these two columns are involved, the first column and the last column. Yes, the first column is C prime D prime and the last column is C D prime. So C and C prime both are present, so they cancel out. What remains with me is now D prime. What remains with me is now D prime.
D
D
prime.
prime.
Is this clear? This is
Yes,
how
ma'am.
we reduce a octet. Now there is another thing that I'd like to point out here. In a four variable Carnot map, please see that whenever we were making a group of four ones, then we the resultant expression that we were having was a two literal expression. Okay, that means two literals got cancelled when we were grouping four ones. Okay, you can look at this even in the other example that we did. Yes or no? Yes or no, students?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
And now when we have made a group of eight, then I'm left with a single literal. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Okay. So this is another question uh, that you can note down and you can try it out yourself later maybe. Just note down the question. Or okay, you can do it right now. Just make it quick. We are doing example number 8, right?
Done, ma'am.
Okay,
Done, ma'am.
okay. So, how does your Kano map look like? Does it look like this?
Yes, ma'am.
Yes, ma'am.
Four corners?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So, what grouping is possible now?
Ma'am, quad.
Ma'am, quad.
Yes. We can make a quad from these four ones. Since these two ones can be considered as
Excuse me, ma'am.
adjacent to these two ones. One second, beta. And
Excuse
these
me,
two,
ma'am.
yes, yes, tell me.
Ma'am, according to the question, I'm
Again, here
Astha.
is a mistake.
Okay,
Yes, ma'am. Here's a
Ma'am, here's a
mistake.
mistake.
Yes, ma'am.
okay. What is the,
Ma'am,
which
I think
term?
instead of AB, we can write AB dash.
In which term?
Ma'am, in third and fourth
Yes,
term.
ma'am.
In third and fourth term, both. If we have to have this Carnot map. Yes or no?
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes. I think these, primes get deleted during the printing or something. That is the problem here. Okay. So B dash, right? Here
Yes,
also a dash is missing, right? And then we obtain these four ones. Yes or no?
yes,
Yes,
ma'am. Now
ma'am.
it's correct.
No. This term is correct because A, B, C dash, D dash is okay. Let us look at it together. So the first term is A dash, B dash, C dash, D dash, which is this, right? The next term is A dash, B dash, C D dash, which is this. Then the next term is A, B, C dash, D dash. So A, B dash, yes, I'm sorry. Yes. So this term should be A, B dash, C dash, D dash. So it will be this one then, and then A, B dash, C, D dash for it to be this term. Okay, so the question should have a prime here on B and a prime here in the fourth term as well. Okay, now I have these four ones. Let us please see how to group them. So for grouping them, we have already said that this one and this one taken together are adjacent to these two ones, and these two ones are adjacent to these two ones. Okay, so
Yes, ma'am.
actually all four can be joined together in a single quad. Okay, all four can be joined together in a single quad. Okay, so how to now reduce this expression? How to now read this expression from the Carnot map? For that, please see, we are going to consider these two rows. This final row, which should be AB dash, it's not written here. It should be, let me see if I can write it. A, B, can you see it? I think it is writing white on white. Okay, let it be. So this is, we know that this term is AB dash, right? So when I look at these two rows, what do I get? I get A dash
A
and
dash
A
and A.
cancel out. So
Cancel
what
out.
I
So
what am I
what
left
I'm
with? B
left with
dash.
B dash.
B dash.
From here I'm left with B dash. Yes. Now let us look at the two columns which are involved. This and this. D and C and C prime cancel out, and what remains is D prime. So what is my final expression? My final
Ma'am,
expression will be B
we
dash
can
D
left
dash.
with
A
the
dash.
B dash.
What will be my final expression? It will be B dash, B dash. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Yes or no?
Ma'am, it will be B dash
Ma'am,
D dash or B
uh,
dash plus D dash.
Beta, it will be B dash, D dash. We are doing SOP now.
Yeah, okay.
Okay.
Okay, ma'am.
The final expression will be B dash, D dash. Any problem?
No, ma'am.
no, ma'am.
Okay, good. Now let us see how to solve a Carnot variable, how to solve a POS expression using Carnot maps. Okay, how to simplify them. I'm going to be sharing another screen with you now. Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Okay. So I want you to solve the questions given in your book as well. Okay. So since they are already solved in book, so I'm leaving them to you as an exercise. Now let us look at the product of sums simplification. Okay. Now what do we do in product of sums simplification is that suppose, for example, this is the question which is given to me. This is the question which is given to me. Okay. And what is this sigma stand for then? I know
Submission.
this
SOP.
stands for the sum of the
Sum.
products. So wherever, whatever min terms are mentioned here, what I will do? I will go and mark a 1 there. Yes or no? In the
Yes.
Yes, ma'am.
cardinal, I will mark 1 in the squares corresponding to these min terms like this. Okay.
Yes, ma'am.
Yes, ma'am.
Now, if we were to do SOP simplification, we would have grouped these ones and obtained expressions, that is the and terms corresponding to each group, as we have been doing up till now. Any problem?
No,
No.
ma'am.
But what we want to look at now is how to get a POS expression from this question. So what we will do is that in all the squares which have not been marked by 1, we will mark them by zeros. First of all the squares which have not been marked by 1s should be marked by zeros. Okay. And then what will we do? We will group them in the same way. We will group the zeros now in the same way that we have been grouping ones, using the same rules. That is, adjacent zeros, largest group possible, no zero to be left, only horizontal and vertical grouping possible, grouping in the uh, powers of 2. Is this clear? Okay.
Yes,
Yes,
ma'am.
ma'am.
So we will group the zeros and we will obtain the simplified expression for each group as we do it for each group of 1. No change there, except that we are grouping zeros. Okay?
Okay, ma'am.
Okay, ma'am.
Now, once we obtain an expression, however, please see, should I write that as equal to f? That simplified expression which I have got by grouping the zeros. These all squares will be marked as zeros now. Yes or no?
Yes, ma'am.
I will be grouping all these zeros now, and then I will be obtaining the and terms corresponding to these zeros. Okay. My question to you is that should I be writing the answer that the simplified and terms that I've got now equal to this f or
No,
no?
ma'am.
PDF complement.
No. Why? Because we had discussed that a min term and a max term are duals of each other, that is complements of each other. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Now, these are min terms, okay? And zeros represent what? The max terms. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
That is how you pick them from the truth table as well. Yes or no?
Yes, ma'am.
So, obviously, the reduced expression that I will get after grouping the zeros should be put equal to f complement, not as f. Am I right?
Yes, ma'am.
Yes, ma'am.
Are we on the same page? Have you understood this?
Yes, ma'am.
Yes, ma'am.
Okay. So the only difference is that after we've grouped zeros and obtained the reduced expression, I put it equal to f dash. But I had to simplify. What was my question? The question was to simplify this expression f in the POS form. Yes or no? Did I have to simplify f dash or f?
F.
I had to simplify f, not f dash. Right? Is that right?
Yes, ma'am.
So, what will we do? We will simply take a complement of f dash. Okay? We will simply take a complement of f dash, and whatever is that expression will be my expression in the POS form. Please see, uh, let us follow example, this example only, okay, that I've taken with you from this book, and to make this clearer. So please see, the first thing that they're doing is this is the expression that they've given me, okay, and now to obtain in the POS form, what they've done is they've marked the zeros. Okay, wherever there are no ones, they've marked the zeros and then they are grouping. So what are the groups possible? The first one is, we can see directly, this is a quad which is possible. This is again a quad which, there is no octet. Is there a octet that I can make here?
No, ma'am.
No. So the next thing, the next big group that I can make is of a quad, right? So this is one quad which is possible. Yes or no?
Yes, ma'am.
Right.
Yes, ma'am.
This is another quad which is possible. And then please see, these these two zeros grouped with these two zeros can again form another quad. So we should have three terms actually. we should have 3 terms, each corresponding to these 3 quads. Yes or no?
Yes, ma'am.
Yes,
Right.
ma'am.
So let us try and reduce. So this is the first quad. What will I get corresponding to this? I will get AB. Yes or no? What is this A dash B dash? The first row is A dash B dash, then this is A dash B, and this is what? AB. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes.
And what is this row? This is CD. Yes
CD.
or no?
Yes,
Yes,
ma'am.
ma'am.
Right. And now let us look at this quad. Okay. So what will I get for this? Here A will get cancelled in these two
B, C
rows.
dash, D dash.
Okay. A will get
B,
cancelled. A will get cancelled. So what I will have is just B. And in these two, in these two, so first thing is that A will get cancelled and I will have B. And when I look at these two columns, the C literal will get cancelled and what I will have is D dash. Okay, from C dash, D dash and C D dash, C will get cancelled and I will have what? I will have D dash. Yes or no?
Yes, ma'am.
Yes, ma'am.
So are you writing it somewhere? So what I've got is AB or CD or BD dash. Yes or no?
Yes, ma'am.
Yes,
But
ma'am.
we just said that we will not equate it equal to F because we have obtained this expression by grouping zeros. Instead, we will equate it equal to F dash. We will equate it equal to F dash. Yes or no?
Yes, ma'am.
yes, ma'am.
Now my final answer will be when I take the complement of this expression. Okay. So let us take the complement of this expression by De Morgan's law. What will I get? A dash or B dash? Yes or no? Please see
Yes,
here.
ma'am.
ANDed with C dash or D dash? Yes or no?
Yes, ma'am.
Yes, ma'am.
ANDed with B dash or D? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Right. So the final expression, please see, is in the POS form. Okay.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Is this clear to everybody?
Yes, ma'am.
Yes, ma'am.
Now please see, uh, instead of giving you the question in the sum of product forms, that means listing out the min terms, the question could have simply put a pi here and listed the max terms instead. Okay. So then what would you have done? The same thing. It would have been one step less. That means here first you have to mark ones and then the remaining squares you mark as zeros and then you start doing your procedure. If you were directly given max terms, then you would have directly put them as zeros. Yes or no?
Yes, ma'am.
Is this clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So this is about the POS simplification. Let me just revise it again with you. Let me take another minute to revise it with you. So it is not difficult. It is just the same as SOP simplification. The only difference is that in the squares which are not min terms, okay, we put zeros. So how do we know which squares we have to put as zeros? Either I will be given min terms in this form of sigma. Okay, so I will put ones in these squares and then zeros in the remaining ones. Otherwise, I could have been directly given in the product of sum forms I could have been given the max terms only. So directly in those squares, I would have gone and put in squares. Okay. After I have the squares on my Carnot map, the procedure is going to be the same. We're going to group the zeros in the same way that we used to group ones. After that, we're going to reduce the expressions in the same way that we used to do for ones. No change there. The only change is that the reduced expression will not be put equivalent to the f. We will put it equal to f dash. Okay, and then take its complement to get the final answer. That is the only difference. Any problem?
No, ma'am.
No, ma'am.
Okay, so there are a couple of questions I think given at the end of this chapter that you should try, which ask you to solve a particular Carnot map in both SOP and POS form. So I think you can do that as an exercise. Is this okay, beta?
Okay, ma'am.
Okay.
Okay, ma'am.
Okay,
So
ma'am.
I will stop here today. I had to do don't care conditions, which I'll do tomorrow. And then we are finished with the Carnot maps. Okay, and then we will proceed to the combinational circuits. Okay, tomorrow as in the next theory class. Okay, so
Okay, ma'am.
I'm sharing the attendance. Please mark your attendance before